In question 1, we want to state the quadrant of the angle theta and state the value of the basic angle alpha if, in question A, theta is 315 degrees, and question B, if theta is negative 105 degrees. So let's think about what angles are in our diagram. So our first angle is going to be 0 degrees, and we go anti-clockwise. This will be 90, 180, 270, and around to 360 again, and we can keep continuing depending on what our angle is. So if theta is 315 degrees, that would be all the way around back to this quadrant here. And at that point, we can draw a triangle. So this is 315 degrees, and the alpha angle is in here. And looking at this picture, that means that 360 minus 315 should give us our alpha angle here. And alpha is going to be 45 degrees. So in this case, alpha is 45. And which quadrant is that? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4 here. So this is in the 4th quadrant. And the alpha angle is 45 degrees. In question B, the angle is a negative angle, so we'll go backwards this time. So we'll go from our 4th quadrant, which is here. This is 90 degrees. So this is about negative 105 degrees, roughly around there. So we form a triangle with the x-axis, and our alpha angle will be here. And in this case, our alpha angle is going to be 75 degrees. And our quadrants, we should label 1, 2, 3, and 4. So in this case, obviously, we're in the 3rd quadrant. And the alpha angle is 75 degrees. In question 2, we want to name the quadrant in which the angle theta lies. And in question A, we're given the fact that cos theta is less than 0 and tan theta is greater than 0. So this is implying that cos theta is negative and that tan theta is a positive ratio. So we should list up our rule as CAST. This rule tells us where the ratio is going to be positive. So in this case, A means all are positive. In this quadrant, sine is positive, but tan and cosine are negative. In this case, tan is positive in this quadrant. And in this quadrant, cos is positive. So looking at this question, it's suggesting that cos is negative, but tan is positive. So that must be in this quadrant here. And as we label them, the quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4. So in this case, we would be in quadrant 3. Okay, in question B, cosec theta is positive, greater than 0. And cos theta is less than 0, which means that cos is a negative number. Again, we label our diagram CAST, and this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So let's look at cosec theta. Stop. Start. Let's look at cosec theta. And it says this is greater than 0. And we know that cosec is the same as 1 on sine theta. So that's implying that 1 on sine theta is also positive. And the only way that can happen is if sine theta is also positive. And our other information is that cos theta is less than 0, which is negative. So which quadrant are we in? So we need sine theta to be positive and cos theta to be negative. So that could only happen in the second quadrant here. So in this quadrant, sine will be positive, but cos is negative. In question 3, we want to write the following trigonometric ratios in terms of their basic angle alpha with the correct sign attached. And the first question is tan 245 degrees. So we need to think about which quadrant we're in first. So let's label up C, A, S, T, and this is where these ratios are positive. And we have 245 degrees. So we're going to come around 90, 180, down to about here. So this is 245 degrees. And in this case, our alpha angle, which is the angle made with the x-axis, that's going to be calculated as 65 degrees. And what we notice here is that tan 245 is positive in this quadrant. So we can write tan 245 is equivalent to tan 65. And that's all that needs to be done for that question. And by using your calculator, you can check that both of these are equal to around 2.14 to 2 decimal places. In question B, we have a negative angle. So we have sine negative 250. We'll label our diagram again, CAST. And we want to measure negative 250 degrees. So we go backwards from 0 to negative 90, negative 180 to around negative 250 degrees there. And in this case, the sine is also positive in this quadrant. So we don't have to worry about the sine so much. But when we look at our angle here, what is this alpha angle here? We can see that this will be calculated to be 70 degrees. So in this case, we can say that sine negative 250 degrees is the same as sine 70 degrees. And you do that in your calculator, you'll get approximately 0.94 for both of these, which shows that we've done it correctly. In question 4, we want to find the value of each of the remaining 5 trigonometric functions. In question A, we're given that tan theta is 3/4, which is obviously a positive number, but the sine ratio will be negative. Sine theta is less than 0. So start by labeling your diagram as CAST, which will tell us where our ratios are positive or negative. And in the question, it says tan here is 3/4, which is obviously a positive number. And sine theta is less than 0, which means it's negative. So now you need to think, where is tan positive and sine negative? And that can only happen down in this quadrant here. So we'll draw a triangle here like that. So we can now write this as alpha. This is our basic angle. So what we're going to have then is tan alpha is 3/4. Tan is positive here. And when we deal with alpha angles, we always use positive ratios. So if tan alpha is 3/4, and we know that tan is opposite on adjacent. So opposite on adjacent would be 3/4. And by Pythagoras, this hypotenuse here would be 5. So we know tan alpha is 3/4 and also is tan theta. We can write 3/4. So then if tan is 3/4, what would be sine theta? Sine here would be opposite on hypotenuse, which would be 3/5. But in this quadrant, theta would be negative. The ratio would be negative. So this is going to be negative 3/5. Therefore, what is cos theta? cos theta is adjacent on hypotenuse, which is 4 on 5, but in this quadrant, only tan is positive. So this will be negative 4 on 5. And then we can do sec theta, which is the reciprocal of cos theta. So negative 4 on 5 is cos theta. So this will be negative 5 on 4 for sec theta. Cosec theta. Cosec is the reciprocal of sine. So that would be negative 5 on 3. And cot theta is the reciprocal of tan theta. So this will be 4 on 3. So those are your 5 other ratios. In question B, it says that sec theta is 2 and that sine theta is less than 0, which is negative. So we know that sine theta is going to be a negative ratio and sec theta is 2. So what is sec theta? We know sec theta is 1 on cos theta. And if sec theta is positive, then cos theta is also positive. So let's label our diagram CAST. So where is cos positive and sine negative? That's going to be down in this quadrant here. And we'll make a triangle there and we'll write alpha in here for our basic angle. So what do we have then? Sec is 1 on cos. So let's write this down. So sec theta, which is 1 on cos theta, and that's equal to 2. Okay, that's from the original question. So that means that cos theta is a half. And then we can use these numbers to label our diagram. So for the diagram, cos alpha is a half. So that would be adjacent on hypotenuse here, 1 on 2. And by Pythagoras, the other side must be √3. So this is the diagram we can use to answer the question. So what do we have then? We've got sine theta. So let's write that down. So sine theta is opposite on hypotenuse. So √3 on 2. But notice that cos is positive here. Sine is negative. So sine would be √3 on 2. But it's going to be negative because sine theta is negative in this quadrant. Cos theta, which we have already, cos is 1 on 2, and cos is positive in that quadrant. What about tan theta? Tan theta is opposite on adjacent, so √3 on 1. But tan here is negative in this quadrant, so it's negative √3, like that. So then what would be sec? Sec theta is already given as 2, isn't it? Sec is the reciprocal of cos, so that's 2, that's given in the question. Cosec. Cosec is the reciprocal of sine, so that's negative 2 on √3. And cot is the reciprocal of tan. So that's going to be negative 1 on √3. So those are the trig functions that you need for that question. In question 5, we want to find the exact value of each of the following equations. And in question A, we have tan 60 degrees divided by 2 minus 1 on sec 30 degrees. So let's think about this tan 60 degrees. We can just use this diagram to help get the answer. So we'll draw a triangle here. And let's put 60 degrees here. And with this triangle, we know that this length here will be √3. The hypotenuse is 2 and this length is 1. That's one of your standard triangles. And from that, we can get tan 60. And we know tan 60 is opposite on adjacent. So that's √3 on 1, which is equal √3. In the original question, it's got tan 60 divided by 2. So that's going to become root 3 divided by 2 minus this second part. So let's clear that section and then we'll do this sec 30 part. So you've got 1 on sec 30 degrees. So 1 on sec 30, stop. Start. For the second part, we have 1 on sec 30 degrees. Now, sec is 1 on cos. So this is the same as saying 1 on cos 30. Okay. Well, that's the equivalent of saying cos 30. So this section here actually becomes cos 30 degrees. So then we just draw a quick diagram. This is 30 degrees. This side is 1. The hypotenuse is 2. And by Pythagoras, this length would be root 3. That's one of your standard triangles. So from that, cos 30 is adjacent on hypotenuse, which is root 3 on 2. So when we write that here, we'll have root 3 on 2. And when we subtract the two numbers, we're going to get 0 for this answer. In question B, we have cosec squared 225 degrees plus cot 330 degrees. So let's do the first bit first. Cosec squared 225 degrees. So let's just ignore the square for a moment and look at cosec 225 degrees. Now cosec is 1 on sine, isn't it? So we can write that as 1 on sine 225 degrees. That's your reciprocal ratio. So let's think about sine 225 using our diagram, and we'll label it as CAST again. That will give us the correct sign. Now sine 225 must be 90, 180, 225 will be down here. Okay, and then we will make a triangle and think about what our alpha angle is here. So in this case, this angle alpha is going to be 45 degrees. So sine 225 could be written as 1 on sine, negative sine 45 degrees. We need to include the negative sign because in this quadrant, sine is negative. So this is the same as 1 on negative sine 45 degrees. So we can write that as 1 on negative. Now, what is sine 45? If this is 45, these things are 1, 1, root 2 by our standard triangle where the angle is 45. Then sine 45 is opposite on hypotenuse. So that's 1 on root 2, like that. And so if you have 1 divided by negative 1 on root 2, you're going to get negative root 2 for this part here. But notice that we haven't squared it yet because we want to do cosec squared 225. So we have to square that number because you're squaring cosec 225. So that's going to give you 2 for this part here. So for the first bit, cosec squared 225 is going to be equal to 2, this part here. So let's clear our diagram and do cot 330. So let's clear that out. We still use CAST, so we should relabel those. So CAST. So cot 330. Well, we know cot is the same as 1 on tan. So that's 1 on tan, 330. So now we need to consider tan 330. So that will bring us around to here. Okay, so this angle is 330. And in this quadrant, tan will be negative. So be aware of that. So our alpha angle here must be 30 degrees. So we can change this to be 1 on tan 330 will become negative tan 30. We used a negative sign because tan is negative in that quadrant. So if that was 30, this would be 1, root 3, and 2. Those would be labeling the sides when that angle is 30. So what's tan 30? Tan 30 is opposite on adjacent, 1 on root 3. So we've got 1 on negative 1 on root 3. So 1 divided by negative 1 on root 3 is going to be negative root 3. So this section up here, cos 330 is negative root 3. So you can see your final answer is going to be 2 minus root 3 for your final answer. In question 6, we want to find the exact value of each of the following expressions. Question A is sine 120. So we want to be able to work out this value without using a calculator. So you can see I've drawn 3 diagrams here and we're going to label them, and this will help us get the answer. So let's label each diagram as C, A, S, T. Remember, this tells you where the ratios are positive and negative. The first thing we look at as sine 120, and sine 120 will come around 90. 180 is that axis, so let's do it to here. So this is your angle 120 degrees. And what we know now is this is your alpha angle here. And alpha there is going to be 60 degrees. Right, so what we're trying to do, we're just trying to change sine 120 into plus or minus sine alpha. And your 120 is your sine theta. So in this case, we can see in this quadrant, sine will be positive. So sine 120 is the same as sine 60. And you can check with your calculator if you like. Those will give you the same value and the same sign as well. So looking at our diagram, alpha is 60, which means that this length is root 3, the hypotenuse is 2, and this length is 1. That's your standard triangle, right angle triangle with 30, 60, 90 degree angles. So sine 60 then would be opposite on hypotenuse, which will be root 3 on 2. So that's the same as sine 120, and that's also equal to sine 60. In question B, cosec 210 degrees. So what's the value of that? Now we know that cosec is 1 on sine. So we just basically rewrite that as cosec 210 degrees as 1 on sine 210 degrees. We do that first because we want to work with sine cos tan, not cosec or sec or cot. So we label our diagram again, CAST as normal. And now we look at sine 210. We need to see what this is. So sine 210, so where is 210 degrees? That's going to bring you around to about here. And we draw a triangle, a right angle triangle there. This angle is your alpha angle here. So your angle was 210, which means that your alpha angle is going to be 30 degrees. Okay, so let's write down sine 210. Is going to be the same as negative sine 30 degrees, because in this quadrant, tan is positive, sine is negative. So if you like to check at this stage with your calculator, and you will find that they have the same value. So let's do it without the calculator. So sine 30, if this angle is 30, this side is 1, this is root 3, and this is 2 by our standard triangle. And we know that sine is opposite on hypotenuse. So that would give you 1 on 2. So negative 1 on 2. That's sine 30, which is the same as 210. But remember, we want cosec 210, which is 1 on sine 210. And sine 210 is negative 1/2. So that's going to give you negative 2 as your final answer. That's cosec 210 degrees. In question C, we have sine of a negative angle, which is negative 225 degrees. So as it's negative, we'll measure backwards from here. And then we'll go to negative 90, negative 180, and negative 225. And I'll make a triangle there. So this is your angle, negative 225. So let's look at which quadrants are positive and negative. So this is CAST. And we can see in this quadrant, sine is going to be positive. So this is our alpha angle, which turns out to be 45 degrees. So we could say that sine negative 225 equals sine 45 degrees. And we use positive because sine is positive in this quadrant. So what is sine 45? If we have a 45-degree angle, these sides will be 1, 1, and the hypotenuse will be root 2. So then our answer is going to be opposite on hypotenuse, which is 1 on root 2. And if you like, you can multiply that by top and bottom root 2, which will give you root 2 on 2 as your final answer. And you can always check these with your calculator to check you've done it correctly. Question 7, given that cos theta is negative 4/5 and that the angle is between 180 and 270, find the value of sine theta and tan theta. So I've drawn a diagram here to help us do this. So let's label up our CAST rule, C-A-S-T. This will keep track of whether our signs are positive or negative. So it says that cos is negative here, and the angle is between 180 and 270. This is the key here. So we know the angle is between 180 and 270. So it's going to have to be down here. So this is your theta angle. Yeah, and this will be alpha here. So what I'm going to do, I'm going to write this as cos theta, which is 4 on 5. Negative 4 on 5 rather, because cos there is negative. So what I'm going to do, I'm going to change that to cos alpha. And we change this to positive numbers because we're just dealing with this triangle now. And when we're dealing with alpha, we keep our ratios always positive. And we can go back to negative signs when we do the final answer if we need to. So cos alpha is 4/5. So look at your diagram. Cos is adjacent on hypotenuse. So this has to be 4 on 5. And by Pythagoras, this length would be 3. So if that's the case, what would be sine alpha? Sine here would be opposite on hypotenuse, which is 3/5. And tan alpha, tan would be opposite on adjacent, which is 3 on 4. Notice how all of these ratios I'm keeping as positive numbers. So now we want to go backwards to our original answer. So if cos 4/5, cos alpha is 4/5, then cos theta was negative 4/5 because cos here is negative in this quadrant. What about sine theta? Sine here is also negative. So this would have to be negative 3/5. But tan in this quadrant is positive. Therefore, tan theta would be equal to 3 on 4. So these are the two actual answers that you wanted. You just need to be careful with your signs, and that depends on which quadrant you're in. So cos is negative in this quadrant, sine is negative, but tan is positive.